So you look like you're still not feeling very well.
I'm just exhausted.
Okay, so we ended yesterday, we were talking about angles. And we talked about how those angles are measured and some of the different ways that they've been measured. The main feature of an angle, of course, is we have a starting point and we go off in a single direction to form a ray. And that ray, if this is point A, I'm just going to label points on that ray. That ray could be labeled ray AB, or it could be labeled ray AC. It has to be named with the end point first, and then any other point along that ray. End point, starting point, however you want to look at it. Then an angle is formed by going back to that same starting point and going in a different direction. So let's label that D. This would be labeled ray AD. Again, any other point along that ray could be used as the second letter. It has to start with A because that is that beginning point of the ray. When we put those two rays together with that same starting point, of course, that starting point is called a vertex. And it forms an angle. And we would label that angle, it could actually be labeled many ways, but this symbol here means angle. DAB is one way it could be labeled. We have to name a point on one side, then we name the vertex, and then we name a point on the other side. So it could also be labeled DAC, could be angle CAD, doesn't matter which order we go in as long as the vertex is the middle point, or BAD. All of those are suitable names. Sometimes we actually use shorthand and we'll just call it angle A, where we just name the vertex. And in this case, that's okay because it's pretty clear that this is angle A here. But if there's a lot of angles, if there are several rays coming off of point A, it might be confusing as to which angle is the angle A we're referring to. Other times we will label them. We might put a number 1 here. So we could call that angle 1. So just to be aware of some of the notation. But the formal way, the most precise way of naming an angle would be with, again, one point from one side, then the vertex, then a point from the other side. A notation you may end up seeing might look like this. That little M in front of the angle symbol stands for the measurement or measure of that angle. In other words, it's asking how many degrees is it? Now, we're not going to get into using a protractor to measure angles in here. We're just going to look at some of the basic calculations. So at this point, you'd have to be told how big that angle is. Once we know how big those angles are, we're going to be looking at doing some calculations with them. So let's say we have an angle here that is 31 degrees. So you might say the measurement of angle ABC is 31 degrees. Now I'm going to go back to that vertex, that point B again, and I'm going to create a third ray like this. Angle ABC and angle CB, I'm going to put point D over here, are what we call adjacent. Adjacent means, well, they share a side. Next to is the term adjacent technically means next to. These two angles are adjacent because they're next to each other. But when it comes to angles, adjacent is a little bit stricter. They must have the same vertex. They both have vertex B, and they must share a side. So they share ray BC is the side that they share here. So those angles are adjacent. And if I were to tell you that angle CBD here is 64 degrees, actually that's not going to work. Let's make it 58 degrees. I can then look at doing some math, some arithmetic with these angles. I could ask, what is the measure of angle ABD? In other words, this bigger angle here. How would I find it? I can add them together. Because these are adjacent angles, I can add the 31 and 58 to get 89 degrees. Is that total angle? That only works if they're adjacent angles. And those adjacent angles can be not only added, but they can be subtracted. Let's say that I tell you that angle FGH is 72 degrees. And angle FGK is 34 degrees. So what that means is this big angle here is 72. And this smaller angle here is 34. And I want you to find the measurement of angle KGH. In other words, find this angle here. Well, I can subtract there instead of adding. So it's just going to be 72 degrees minus 34 degrees, which is 38 degrees. So because they're adjacent angles, they're additive and subtractive. That little, if we make an angle that has that little symbol in the corner, that's actually a box. It's technically a square. That square means it is a square corner. What's our mathematical name for a square corner? Right, well, not really a right triangle, but right angle. That's okay. We're going there next. So it's a right angle. The reason it's called a right angle actually comes from construction and other applications, but you know, you're setting a wall up, you want it to make a square corner or a 90-degree corner with the floor. You want the walls to make a 90-degree or square corner with each other. So if you're setting it up, that is the right angle to have it at. That's where that term right angle came from. And of course it is 90 degrees. Angles that are smaller than a right angle or smaller than 90 degrees are called acute angles. Angles that are larger are called obtuse. You can think, have you ever heard the terms acute thinker or obtuse thinker? An obtuse thinker is someone who sees the whole big picture but doesn't focus in on any little piece. An acute thinker is the opposite. They focus in, they see all the little pieces, but they don't see the big picture. Okay, so now that we have those special angles and we went over measuring angles yesterday, I want to talk now about pairs of angles, special pairs. Of course, we talked about a line, a straight line like that, or really what it is we started out in one direction, we turned and we went back complete opposite direction. What size angle is that? 180 degrees. So 180 degrees is called a straight line. If I have an angle here that is 71 degrees, how big does this angle over here have to be? Well, Perfect. 180 minus 71 is 109 degrees. This is a 109 degree angle. Two angles that add up to 180 degrees are called supplementary. Now these two angles are adjacent and supplementary. So it's actually something a little bit stronger called a linear pair. They're just a pair of angles that are forming a straight line. If this were a formal geometry class, we'd talk about the relationship between linear pair and supplementary and the connections. You can use the fact that two angles make a straight line to say that they're supplementary, which was kind of common sense. Or you can use the fact that they're supplementary to say that you can put them together to make a straight line. For this class, the only term we're really concerned with is the supplementary. We're not worried about the linear pair. Another condition we could have is, let's say we have a square corner or a right angle, and we have an angle cutting into that. Let's say this angle here is 67 degrees. What's this angle up here have to be? 90 minus 67, which will be 23 degrees. That is what's called complementary. Complementary angles add up to 90 degrees. Now, if you're anything like me, when I was learning this, I could remember those words, but I couldn't remember which one is which. I knew supplementary and complementary, but I couldn't remember which was which. But remember, 90 degrees is a right angle, and you get complements when you are right. So I'm asking you to find the supplement of 121 degrees. What's it going to be? Perfect. 180 minus 121, or 59 degrees. If I tell you that this angle here is 43 degrees, what's this one have to be? (180 minus the 43), 137 degrees. Good. If I were to take this line here and extend it that way, knowing that this angle is 137, what does this angle have to be? Yeah, 180 minus 137 is going to be 43 again. These two angles here are called vertical angles. Because these two form a straight line, they have to be supplementary. Because these two form a straight line, they have to be supplementary. So the technical definition of vertical angles are two angles that are supplementary to the same angle. They will always be the same. And they appear in this drawing configuration here. There is a second pair of vertical angles in this drawing. Can anybody tell me what it would be? We have the 43 and 43. You got it. Be 137 and 137. So anytime there's two intersecting lines, there will be two pairs of vertical angles. Pretend that's straight. Whenever we have two lines, two or more lines, I should say, that are cut across by another line, this line that cuts across them is referred to as a transversal. transversal cuts across lines. Now, if it's just two lines and one cuts across it, it's just considered intersecting lines. So you have to have the third line. You have to have two lines originally and another one cutting across it. Or you might have 5 or 6 lines originally and another one cutting across and make transversals. This situation, however, is not terribly interesting. It's much more interesting when we have lines that are parallel. So it's our transversal cuts across here. If I tell you that this angle here is 127 degrees, I now know all 4 angles around this section here because of the between supplements and vertical angles. Which angle, I'm going to call them 1, 2, and 3, which angle has to equal 127? 3. What about 1 and 2? What do we know about them? Perfect. They have to be 180 minus 27. They have to be supplements of the original angle. Oops, 180 minus 127. So 53 degrees. Now, if we go down here, some of you probably already know this, but basically, if I slide this line up, those angles lay right on top of these angles. So to slide this down, this angle here has to be 53. This one has to be 127. This one has to be 53, and this one has to be 127. Now, again, if this were a formal geometry course, there are a lot of rules out there talking about if you have parallel lines cut by transversals, there are something called alternate interior angles. These two would be alternate interior angles. They have to be the same. These two would be alternate interior angles. They have to be the same. Alternate means they're on opposite sides of the transversal. Corresponding means they're on the same side of the transversal. Corresponding interior angles would be these two. Those have to be supplementary. Or these two. Those have to be supplementary. There's alternate exterior angles. Alternate still means opposite sides of the transversal. Exterior means outside of the parallel lines. So these two are alternate exterior. They have to be the same. These two are alternate exterior. They have to be the same. There's corresponding exterior angles. Have to be supplements. There's just corresponding angles. Have to be equal. Corresponding angles mean they're on the same side and they're in corresponding positions. We're not going to memorize all those rules. All you need to know is when parallel lines are cut by a transversal, all the angles formed are either equal or supplementary. And usually you can figure out which ones are which. And the only way it'd be tough is if you had a line that went through here almost perpendicular to it. Which brings me to one of the next words we need to talk about, perpendicular. We have parallel here. These lines are parallel. What does perpendicular mean? They create a 90-degree angle. They create a right angle. Perpendicular is actually slightly more powerful than at a saying at a right angle because we're used to thinking in 2 dimensions on a flat sheet of paper, and making a right angle and being perpendicular are pretty much the same thing there. But remember, geometry exists in 3 dimensions. And so in space, if I had a pencil or whatever coming right out of the board at me, let's see how well I can handle my artistic skills here. So let's say that's a piece of paper. There's a pencil coming out of it, or a line coming out of it. Perpendicular means that no matter what direction I measure it in, it's going to form a right angle with that surface. So perpendicular means forming a right angle in every possible direction. But again, in 2 dimensions, it means it forms a right angle. So we have parallel, we have perpendicular, and then we have lines that are like this, which again, in 2 dimensions, you often just say they're intersecting lines, because in 2 dimensions, if they're not parallel, they're going to intersect. But in 3 dimensions, they don't have to be parallel to not intersect. I can have these 2 lines. They will never intersect, but they're not parallel. The technical definition of parallel, is everywhere equidistant. What that means is always the same distance apart. So in 3 dimensions, parallel lines are always the same distance apart. So in 3 dimensions, lines that are not parallel don't have to be intersecting. So in 3 dimensions, we use the term oblique. And in 2 dimensions, oblique means they are not parallel and they are not perpendicular. So oblique basically means there's no special relationship between them at all. Okay, so let's take a peek at some interesting problems here. As I look at a situation like this, I have 3 oblique lines, 3 lines that intersect. If I give you this angle here is 112 degrees. There is a relationship between that angle, this angle, and this angle. Well, how so? If I start out moving in this direction here, and I turn to go this direction. When I get here, I turn so that I'm going in this direction. When I get here, I turn so I'm back in my original direction. How many degrees have I turned? I've made a complete circle, or 360 degrees. Those 3 angles must add up to 360 degrees. So if I call this, I'll call it angle 1, 2, and 3. Must add up to 360 degrees. These 2 angles, I'll call this angle, these angles 4, 5, and 6. Angles 1 and 4 have to add up to how much? Yeah, 180. They make a straight line, right? So I've got 1 plus 2 plus 3 is 360 degrees. 1 and 4 is 180 degrees. Any other combinations that have to add up to 180? 2 and 5, and 3 and 6. Well, it would be nice if I could figure out what 4, 5, and 6 add up to. So if I combine these here, if I add all of those together, what's 3 times 180? 540 degrees, right? And I'm going to take away 1, 2, and 3. I have to subtract 360 degrees. So those angles are gone. I'm left with 4, 5, and 6 that have to add up to 180 degrees. That will be true of every triangle we make. Every triangle, these are called the interior angles. That is referred to as the interior angle sum. Has to be 180 degrees for triangle. So let's combine that with our parallel lines. Let's say this angle here is 51 degrees. And let's say that this angle here is 82 degrees. I want to find angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And while we're at it, we just will find 16 as well. Well, let's start out with the easy part, right up here. What's angle 1 have to be? 180 minus 51. So that's going to be 129. How about 3? 51 and 2? 129. Okay, now let's look at the 51 here. Are there any other angles that have to be 51 degrees? The 12 and the 14 have to be. Because these are the parallel lines here, and this is my transversal. So this angle would lay on top of that one, this angle would lay on top of that one. Are there any other angles that have to be 129? Well, the 13 and 15. Well, now that I know that, how can I now find these angles up here or these over here? Well, I'm going to go in the middle here. I've got 82. What's angle 16 have to be? That's a straight line, right? So by 180 minus 82, it's 98 degrees. Now, we weren't asked to find them, but I can find this angle here is going to be 98, and this one's going to be 82. Now that I know that, I can find this angle. How would I find that angle? 180 minus 82 and minus 51. Because those three angles of the triangle have to add up to 180. So what's that come out to be? 98, 47 degrees for that angle. Now that I know that's 47, what's 8 have to be? 180 minus 47 is 133. What's angle 9 have to be? 47. Angle 10? 133. Up here, what's angle 5 have to be? Well, this one would lie on top of that one, right? So the 133 is actually going to lie on top of that. So that means the 6 has to be 47, 133, 47. Basically what you have to do is you have to ignore this line here, pretend it's not there. Oops, come here. Pretend it's not there and see, okay, These two have to be the same. That's not what I was trying to do. Put that line back in, then you ignore this line and look at it and say, okay, these two have to be the same. We'll put those lines back in. Then, of course, the middle here allows us to go from one to the other. What do you think? Loads of fun? Maybe not so much. This comes to a single point here, by the way. This angle here is going to be 31 degrees. And this angle here is going to be 82 degrees. I want you to try in your notes to find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for me. Let's take a look and see how you're doing. Of course, up here, these will be easy to find. 1 is going to be what? Careful. 149, right? 180 minus 31. So then 2 has to be 31, and 3, 149. Now looking at those, are there any other angles on here that have to be either the 149 or the 31? This one right here has to be what? 31. And the reason for that again is, take this line and pull it away, it's just that. So this has to be 31, 149, 31, 149, right? So put this line back in it, knowing that it has to be 31. This over here now has to be, because this is a straight line, those 3 have to add up to 180. It's going to have to be what? 67. Good. That's just 180 minus the 82 and minus the 31. Now that we have those 3, this one has to be 31 because it's vertical with that one. What's 10 here have to be? 82 because it's vertical with that one. And 11? 67 because it's vertical with the 67. And now again, if I pull this line out and ignore it, what do I know about angle 7 up here? It has to be the same as 11. It has to be 67 degrees. Of course, 5 is also 67. And then 4 and 6 will be found by doing 180 minus 67, or 113 degrees. So it's kind of like putting together a puzzle. The big trick to it is if you've got more than one transversal, is pulling one of them out like I did there. Once I pull this one out, it's easier to see that, hey, this is 67, this has to be 67. These two add up to 113, that one has to be 113. That's a skill that a lot of students struggle with, is being able to ignore part of the figure. It'll take some time to get used to it. Okay, so there's nothing new today. There is still a quiz that was assigned yesterday that is due tonight at 11:59 p.m. And there is a homework assignment. It is due Monday. You guys have a great weekend.